Hello and welcome to Slooh and episode 2 of our live coverage of the Supermoon Trilogy. And today it's the turn of the super pink moon. Now, I'm Paul Cox, and the Slooh team tonight are scattered around the globe to bring you this live event. I'm hunkered down on the south coast of England with my dog, who you may hear making strange noises in the background. Our studio is still operating in Connecticut, and our guests are scattered across the USA to bring you this live show tonight. Now then, we watched the super worm moon, if you remember, last month, and we'll have coverage of the super flower moon in May, where we're going to be focusing on the impact the moon has on wildlife. But before we get into all of that, we've got a few exciting announcements before we get into kind of super moon mode. Now then, with the help of our partners at the Catholic University of Chile. They manage our Slooh Southern Hemisphere Observatory. In an hour and a half's time, we're going to have our first all-Spanish broadcast, La Superluna Rosa. Doesn't that sound a lot better than Super Pink Moon? There's, I don't know, there's some romance there or something like that. But anyway, it is going to be hosted by our observatory's resident astronomer, Daniela Fernandez. So that's going to be really exciting. I'm going to be watching that. Oh, now, look at that. There's our first view of the supermoon. Now I'm going to take you through all of the live feeds tonight. We've got some really special ones. We've got some great ones coming from Chile, and we should see there the moon rising above the Andes Mountains. So we'll go through those a little bit later. But anyway, another piece of special news. We have an antidote here at Slooh. If you and your kids are in lockdown at present and going a little bit stir crazy, we were just talking amongst the Slooh team a minute ago, and there is a little bit of stir craziness going on in families at the moment. Well, you need to check out. This is a bit of a sales pitch, but we make no apology for it whatsoever, because this is going to save some families, right? We have a quarantine special. We've launched a student membership, which includes control of all of Slooh's telescopes. We'll be talking about those throughout the show, and we'll be seeing live feeds as well. And that includes the mighty half-meter telescope in the Canary Islands. And for a student membership, it costs $20 a year for unlimited use of all the telescopes that we're going to be using tonight. Student members also get access to our NGSS curriculum-driven quest. Now, those are a series of self-directed learning activities. The self-directed bit, parents, is the thing that you need to tune into. No astronomy background is required, and students can ask our astronomers questions with our Ask an Astronomer Anything feature. Now, we're going to have loads more information about that a little bit later on when Slooh's Director of Education, Russ Glenn, joins us to look at two of the moon quests that launched last week. And the news keeps coming. I promise you, we are going to get to the supermoon any minute now. But this is international news here at Slooh. A big shout out to all of our new members watching from Sweden tonight. Now, Slooh's Swedish ambassador, Beatrice Dax, launched sweden.slooh.com today, and a new Nordic astronomy club for you folks up there at the top of the world. That's the latest international version of Slooh. And if you're interested in learning more about becoming a Slooh ambassador for your country, then email me at paul@slooh.com. And finally, one last piece of news. If you're watching on Twitter, Facebook, or YouTube, hop over to slooh.com. Join our global community of students, amateur astronomers, and space enthusiasts who control these robotic telescopes every night. Members watching at Slooh can switch between all of our live feeds tonight. We're going to have a look at those any second, and snap their own images, just like they do every night, to capture images of distant galaxies and nebulae, star clusters, supernovae, asteroids, and even the green comet that this week is thought to be breaking apart. Now then, back to our event for the next hour. We're not just gazing at galaxies, nebulae, star clusters, and planets. Instead, we are far closer to home watching this, the full moon. And this particular full moon just happens to coincide with when the moon is closest to Earth in its elliptical orbit. That's what makes it a supermoon. And this one is a special one. It's the largest of 2020. Now, we talk more about what makes a supermoon super when I'm joined by our special guest in a few minutes' time. But before we welcome my first guest, Bob Byrne, I'm going to take you through a quick tour of our feeds tonight. Now, we can actually go back. The view that you were seeing, the Canary All Sky camera, this is a special camera that looks at the entire sky. It looks like a blue sky, but actually, look, there it is. That's actually the moon. You can see we've got a little bit of cloud there. Now, that would destroy those images of galaxies and nebulae and stuff like that. But for the moon, it's so bright, especially a supermoon. We'll see straight through those clouds, so we get some good views. So let's go now to our Canary 2 ultra wide field. And this is an important telescope because this gives us this whole disk view of this supermoon. Now, we are going to be talking about all of the different features that we can see on this moon tonight. And it's strangely, we're going to be talking as well. It's not the best time to observe the moon, but there are a few items on there, a few features on there that actually are perfect. This is perfect timing to observe. We've also got a close-up view using our special Canary 4 solar system telescope. Now, this looks a little bit fuzzy to me, so this one is going to be affected a little bit by those clouds. But we've also got coming online. Now, these might not come online within the next couple of minutes, but within the next 10 minutes, we've got our Chile telescopes coming online. Now, when they come online, if you're watching at slooh.com, flick over to the tabs on those feeds because the moon is rising. So some of the images might be black. The video stream from the Chile 3 lunar telescope, that might be black to start off with, but keep your eyes peeled on that because we should be seeing the supermoon rise above the Andes mountain range. So those are our feeds. Don't forget, we'll have them up on screen all the way through the show. But don't forget, if you're watching at slooh.com, you can switch between all of those different feeds as you like and the live show, and you can snap your own images as well. Now then, it is time to welcome our first guest expert of the show. He's been a firm favourite among Slooh members since we started way back in 2003, would you believe? His dulcet tones, actually, are the ones that narrate many of the live telescope missions. It's none other than Slooh astronomer and author Bob Berman. Bob, good evening. How are you?
Great to be here. Thanks, Paul. Good to see you.
Wow. You're in lockdown on the east coast of the USA. Is that right, Bob?
We're in lockdown in near beautiful Woodstock, New York, with bears around us and observatory in the backyard. And we could stay here 5 years. We wouldn't mind it.
That's great. Bob, first of all, before we start talking about what the supermoon is, what do you make of this image stream coming in from the Canary 2 ultra wide field telescope? It's pretty cool, isn't it?
Yeah, very cool. Very cool. Because the moon is one of those objects that you don't need high power. Often you don't even want high power. Some of the most beautiful views are with either low magnification, wide field, or just the naked eye. I mean, those
Yeah.
of us who have seen a total solar eclipse where the moon is in front of the sun, boy, you don't want too much magnification. There it is. And the views that we're going to have now tonight with this super moon, I'm looking forward to it.
It is. It's going to be great. And we're going to be talking about all of these features. And in fact, I know your particular favorite is showing up really, really well in this view. So we'll talk about that a little bit later. But first of all, the moon changes size. And it changes size because it's got an elliptical orbit, hasn't it? It's not a perfectly circular orbit. Is that why we're seeing the moon change size over the course of a month?
Yeah, yeah. Almost nothing in the universe is circular. It's very hard to find a truly circular orbit. Of the planets, Venus comes closest. Of the moons of the solar system, the Galilean satellites of Jupiter come closest to being circles. If you look casually, if you were an alien approaching it and could see their orbit traced out as a circle, as a line, it would really look like a circle. But our moon isn't even close. So yeah, there's every month. Sometimes it's closer, sometimes it's farther, and then that ellipse itself changes shape depending upon factors. We won't get into them right now, but it means that some months it can actually come closer than others. And this is the closest moon of the year. So very cool.
And there's a nice little diagram explaining exactly that. We've got a couple of terms there we'll explain in a minute, perigee and apogee, because the true astronomers used to call this, well, astronomers still do, but this is a perigean full moon, isn't it? But the term supermoon is less of a mouthful. So, what is a supermoon then, Bob?
Well, yes, an astrologer, but I can only say the word. Astronomers and astrologers are that's like oil and water. So, but an astrologer coined the term. I think it was in the late 70s for
Mm,
when the moon is unusually big, and at that time, a supermoon would be the closest moon of the year, or maybe even the closest it's come in 10 years. Nowadays,
mm,
often it's just called, well, almost any moon that's closer than average, so the term is not defined, it's kind of very loose, but certainly tonight's moon is a supermoon. If you're going to define it as a close moon, this is the biggest moon of the year. Still not big enough so that if you go out, you're not going to look up and say, whoa, that moon looks bigger than any other. You can't really
yeah.
see it with just the eye. Nonetheless, it is closer and bigger. Yes.
And that's an interesting one because we often I love this term supermoon because it captures the public's imagination and it gets people to look up actually at an object which is so familiar a lot of people don't even bother anymore. Oh, look, there is the Chile telescope coming online. This is the Chile 1 wide field telescope. It's kind of giving us this average view. I wonder if we've got the video lunar telescope running at the moment. Oh, it gets me excited. Sorry, I get, me, Bob, I see a lovely picture like that and I'm like a dog with a squirrel. Anyway, what I was saying was, I just love Supermoon because it captures the public's imagination. But what you're saying is right. I looked at it out of the window tonight. Actually, I popped out into the garden, and the moon was rising. And when we see the moon close to the horizon, we get this lunar effect, um, which makes it look larger than it is. But could I tell that it was bigger than last month's full moon or the previous month's full moon? Probably not. But
No,
it
no,
is.
not looking at it. And if you had an instrument like a filar micrometer that actually accurately, scientifically measures its size, then you could measure it as being different. But even then,
So,
things are a little screwy because just as you say, the moon always looks big when it's low. That's
mm,
a sort of a psycho-optical illusion called the moon illusion. But it's actually
mm.
bigger when it's higher because you're closer to it. Earth's rotation carries you closer to the moon when it's highest in the sky. That's just when it looks smallest, but if you could measure it, that's just when it is biggest. So there's sort of wheels within wheels of things going on with this.
So it is really difficult. I look outside. I know this is the largest full moon of the year, but the problem is when I see it in the sky, I can't compare it to anything. But when we can do this, and we can compare it to a small moon, actually in this case, a micro moon, which is the apogee moon, the smallest moon of the year and the largest moon of the year. We took these back in 2015, I think. Then it's very easy to spot. So there's a 14% difference in the angular size of a mini moon versus a supermoon. But there is one thing that does change quite a lot, and that's the brightness, isn't it, Bob?
Yeah, it's about 38% difference, and that is a difference. The brightness that the moon is going to cast on the countryside. If you're away from city lights and you go out, you'll see tonight's moon. If it looks bright on the countryside, of course it'll be brightest. If you have a snowy landscape, hopefully by now in April you don't have snow anymore. But if you do, that'll make it brightest of all because the combination of a brighter than normal moon that's tonight with a more reflective surface. The moon reflects about 96% of its light on fresh snow, whereas
Uh-huh.
grass only reflects about 16% of its light. So, very big difference in how bright the countryside becomes, depending upon what you've got out your window.
And this is another little overlay I did. That wasn't really the color of that moon. We'll talk about this in a sec. It's not actually a pink moon, but it was just to differentiate the super moon in the background, the mini moon in the front. So, Bob, are um, are supermoons always full moons? And this diagram is suggesting that it's not. It's suggesting that
No, no.
later on this year, we've got something else.
Yeah, yeah, you're gonna have a new moon that's a supermoon. The reason it's likely to be a new moon or a full moon is because that moon's orbit, look at it. You can see we've drawn an ellipse, not a circle, of the moon going around the Earth. That ellipse becomes more elliptical, more stretched out when, from Earth's perspective, the moon and the sun are either in the same direction, which they are in the top picture, that would depict a new moon, or in the bottom picture of a full moon, they're still on the same line. And that tends to make the moon's orbit change shape so that it can come closer to us. So that's why you'll see the perigee moon, the closest moon of the month, and closest moon of the year will tend to happen at full moon or new moon.
So we were very fortunate last year, 2019. There was a series of supermoons then, and the first of those also coincided with there being a lunar eclipse when the moon passes into Earth's shadow. But if you've got a super new moon, which might coincide with a solar eclipse, that must mean that the moon's size in comparison to the sun is a lot larger than a normal solar
And
eclipse. So
that's
does that mean it lasts longer, Bob?
Oh yeah, that's just what happened in July of 1991. We had a the longest eclipse of this century, of for the next century,
Oh,
and that was an eclipse that was almost 7 minutes long, because exactly what you said happened. The moon was essentially a supermoon, so it appeared larger, and therefore it took longer to cover up the
okay.
sun and then uncover the sun. So it was an extraordinarily long eclipse.
Wow.
Yes.
Now, Bob, we're going to talk about your favorite lunar feature in a second, but I did want to share with viewers an image that was captured from the live telescope stream last night by Carol Botha. And this shows something really extraordinary to me. The first thing actually is this is the thing I love about astronomy, Bob. I had never heard about this crater before. It's called Crater Bailey,
Yes.
and
Well,
it's at the south pole of the moon. And apparently, Carol, in her write up, she shared this image in the Slooh clubs and a Slooh observation for other members to look at, and explained, the history of this thing. It's a quite difficult to see, but she used this term called libration. Now, we don't go into too much kind of scientific terminology here, but libration is an important one, isn't it, for people who want to spot features on. Oh, we got this is the lunar telescope in Chile. It's coming online. But tell us about libration, Bob, while we watch this hopefully come into view.
well, I think most people know that the moon keeps one side toward us, and that's because, and all the moons in the solar system do that. All the major moons keep one side toward their parent planet because the tidal forces just lock it in place. Now, the moon rotates once every 27.32166 days. That never changes. But Kepler told us by his second law that as the moon goes around the Earth, it speeds up and slows down. When it's closest to the Earth, as it is tonight, it whips around our planet faster. When it's farthest away at apogee, it travels at a slower speed. So the combination of its rotation being exactly even, but its revolution around us not being even, speeding up and slowing down, means that it doesn't really just quite show one side toward us. Sometimes it gets a little ahead of itself or behind, and then
Okay, so
we can peek around one side or the other and see a little bit more of the
okay,
moon. Also, because the moon's orbit is inclined 5 degrees from the Earth's sun plane, sometimes we're above it a little bit. We can look over the top a little bit and look
okay,
down at the north. Sometimes we're underneath it and can look up and see a little more of the south. Those are called the librations. Nothing to do with like drinking a vodka martini. Let's say that's a libation. But maybe you'd be driven to that if you think about all these movements too much. I mean, even Isaac Newton said, famously, he said that just thinking about the moon gave him a headache because it's doing so many different things. But that's one of
okay.
them. And so whether we see Bailey or not, Bailey's one of the three largest craters, Bailey and Schickard and Clavius among the biggest craters. We're talking about 200 miles across. That's big for a lunar crater. We don't always see it. It all depends upon whether the libration has let the South Pole tip a little bit so that we're looking under and seeing it more clearly.
Okay, Bob, we've got a couple of minutes left on this. So sorry, we've left your favourite object. Very little time to talk about. But I asked you, what's your favourite feature on the moon? Because we're going to be talking a lot about different types of lunar feature later on in the show.
Yes. Well,
And you said Tycho. So
well, for
what's
this
Tycho?
time of the Tycho is one of my favorite for the full moon tonight. If it were the first quarter moon, or let's say a 10-day-old moon, 3 days after first quarter, then it would be that crater on the left, which is Copernicus. That white crater on the left, Copernicus, with its terraced walls. This is a beautiful crater, just under 60 miles across, sitting all by itself near the Oceanus Procellarum, a big smooth lava area. Boy, you can't get much more beautiful than Copernicus. But at this time of the month, the sun shines straight down on Copernicus and it just whites out. You don't see it very well. So at this time of the month, probably most people's favorite feature would be that thing in the bottom. Look at it. That has all
Yeah.
those rays coming out of it. It looks like a necklace. If you could see a woman's profile in the moon, which I'm seeing right now, it helped if you went to college in the 60s. Those of you know what I'm talking about. To see things like this, but there's that white feature with rays coming out, and look at that. Some of those rays stream across the entire 2,100-mile
Wow.
diameter of the moon, and that is a very recent crater. It only formed 108 million years ago, which was just
Wow.
Achu. In
Yeah.
yesterday's, it was yesterday in astronomical history. So maybe we can talk about it a little bit more later, but it's stunning because of that ray system. The ray
We
system
will.
is material. It scooped up material from underground and then hurled it away. That's what we're looking at.
We will talk about it more later, Bob, because it would be a pity not to do that, especially when the Chile 3 Lunar Telescope video stream comes online properly for us. But for now, Bob, thank you very much. We're going to see you a little bit later in the show where you're going to be answering a whole bundle of questions that we've had from members. So we'll see you a little bit later. Now, for the rest of
Okay,
you,
great.
joining us after this very short break is Slooh's Director of Education, Russ Glenn. And he's going to talk about how students and educators can use Slooh. And we're also going to be learning about 6 types of lunar features as we take a live tour of this full pink supermoon. And don't forget, you can join in the conversation and ask any questions in chat if you're watching at Slooh. Don't go anywhere. We are going to be right back after this short break. Hello and welcome back to Slooh's live coverage of the full pink supermoon tonight. We've just been looking at some of the live feeds. This is, I just need to move my screen over a little bit. This is our Chile 1 telescope, giving us this superb close-up view. We've got our Canary Islands 2 ultra wide field, which is the one giving us the full disk. I have been told by operations Slooh, Chile, that we have got a bit of cloud down there. So the Chile 3, there are so many Slooh telescopes now. I really have to think about which one is which. The Chile 3 lunar telescope, which is giving us a video feed tonight, that's affected by the clouds more than the others, but we are keeping on trying with that one. But anyway, let's now move on to our next segment, and I am delighted to welcome Slooh's Director of Education, Russ Glenn. Good evening, Russ. How are you? How's lockdown treating you and the family?
Oh, Paul, we're doing all right down here. We're down here in Dripping Springs, Texas. We've got our stay-at-home orders, and just making the best of it. Making the best of it. A lot of
Excellent.
Slooh going on here.
Exactly, and there's a lot of Slooh going on around the world as well. This is amazing, isn't it? So I'm in
It is.
England. Where are you? You're Florida, is it, Russ? No,
Dripping Springs,
Texas.
Texas. Dripping Springs, Texas. Yeah, I'm just outside of Austin, just west of Austin. So, any folks from
Okay.
Texas listening in tonight, you're right nearby. So, give a shout.
And the Slooh Studios operating all of this and calling us all in. They're in Connecticut, so Slooh's a real global family, the Slooh team and our global community of members. Now, Russ, we are going to talk about a couple of things at the moment. We want to. I did head off the show and tell parents and students that we've launched this new student membership. So we're going to talk a little bit about that, but then we're going to be going straight into diving into some of these live views, and we're going to be talking about the various lunar features that are featured in our Lunar Features quest. That was a mouthful, wasn't it? But anyway,
Yes.
to
You handled it
start
though.
off,
You handled it well, Paul.
did I? Thank you very much. Too many features, way too many features for a single show. Now, listen, let's start off. What is new with Slooh Education, Russ? What's going on?
Well, yeah, the most exciting thing, Paul, I think, is that we've got we've got tons of students joining us, which is fantastic. Tons of students joining us.
Brilliant.
But we've also got some classrooms joining us, and that's really special because those classrooms, when they join on, that's a group of students who are, obviously we're all at home right now, but they're able to be connected through Slooh. They're doing their work on Slooh. They've got a private astronomy clubhouse that they are all part of. And if I want to do a quick shout out to the new
Oh,
classes
do,
that
yeah.
came on this
Yeah.
week. I mean, we've got just the other day, Kent's Hill School in Maine, their
Hi,
astrophysics
everybody.
class. Yeah, they jumped on, and they might be out there listening. I hope you guys are. If you are, give a shout. It's awesome that you jumped in. The Galloway School in Atlanta, Georgia, you guys came on. Allen Academy in Brenham, Texas. We're so glad to have you guys. And these kids are on fire. They're blowing up the gravity point board if anyone's been watching. So they're the ones to beat right now,
Excellent.
I think. Challenge to the rest of the schools. Hopefully the challenge is accepted. And then the Brunswick School in Connecticut also came online. We got some great schools coming online, and they're really out there doing the quests. I mean, they're having a good time with that, but they're also able to access all those telescopes, take some pictures, make some observations, really enjoying their time together in researching astronomy. It's excellent. It's wonderful to have them on board, and I'm thrilled.
If schools or institutions want to, get involved with this and get their classrooms, even though they're scattered at the moment, involved with Slooh, what do they need to do, Russ, to get involved and to get some memberships for their students?
The easiest thing to do would be to email me, russ@slooh.com. So just shoot me an email. I'd love to get you on board. Love to show you what we've got. I think you'll like it. It's wonderful for all kinds of age groups. We can talk about that when you give me a shout. You can also
Okay,
go to our website under the education section. You can schedule a time with me on my calendar, and love to have you. Love to have you.
and individual students and parents, they can create an account just by clicking the Join Now button. Is that right?
Yes, and that's wonderful. If you're an individual student at home, you're not with your class, you can still join this wonderful community. Make sure you join, and make sure you pop into Students Corner Club. That's where all the students go. We funnel you guys there, and gives you an opportunity to share your successes, share your images, share your excitement for space with your fellow students all around the world, which is what's amazing about this. It's a global community as Paul's mentioned a couple of times, and we love that.
So Russ, students come in, they look around Slooh, they can use the telescope straight away, but as we said at the beginning, you don't need to know anything about astronomy to do some sleuing. You're running some astronomy lessons, aren't you? Live astronomy lessons. When's the next one due?
Yes. So we've got, lesson one, Paul, you were there for that one. We had a great time going through the Cosmic Explorer. That one's available on YouTube. You can check that out. Our next lesson is in just a couple of days. So, this Thursday, 1400 UTC. For those of you who need a little bit of a guidepost there, that's 10 a.m. Eastern Daylight Time here in the United States. You'll have to calculate the rest depending on where you are in the world. We'd love to have you there. We're going to be doing a solar lesson, looking at one of our solar quests. Nice. And also just checking out our solar scope, which is up all the time, whenever there's a sun to be seen. So, we're excited about that, and hope you guys check it in. I hope you guys check it out and log in during that time.
That you'll probably share this during the lesson, but people looking at the sun through our special, it's a very special solar telescope, literally see the sun in a whole new light. Now, we've got it up on the screen. Let's talk about quests before we look at lunar features. What new quests have we launched for students to go through, Russ? What do we got?
So a couple of really great new quests. The developers at Slooh are constantly bringing new things online for you, any subscribers, not just students.
Yeah.
Anybody can jump in and enjoy these quests. But the two new ones that we've got a Lunar Phases quest, which for anybody who's wondering about the lunar phases and wondering about how they can remember that and get to know it better. This is a fantastic way to learn it, because you go through the phases of the moon yourself. You capture those images, you load them up. You're going to learn these phases, and your retention is going to be amazing. You'll be able to wow your friends and family with your knowledge of the lunar phases. So, jump in there, and then we're going to be talking more about this one. But this is our other new lunar quest, is the Lunar Features, where we take a look at all the exciting things you can see on the surface of the moon. And we're going to be talking about that one. But the Lunar Phases one is a 100 level. It's a nice starter quest. So when you're just joining Slooh, get in there, do this nice starter quest. And then once you've gotten your feet wet a little bit, learned a little bit about the telescopes, know what you're looking for, know how to plan a mission, all that good stuff, then you can jump into our 200 level Lunar Features quest, which is beautiful quest. They're amazing.
It is. I looked at actually after we launched the Lunar Phases quest, we launched that just in time for a new moon coming along. Now we can't actually see the new moon. We can see an early crescent moon, and I looked on the system the other day. We've got several hundred people who have already started that quest, but of course it's taking them a month to gather up all of their images. And tonight, of course, they've got a perfect one for the full moon slot there, because they've got a supermoon. Maybe we should have retitled that slot in the quest for tonight. But Lunar Features then. So we're going to talk a little bit more about this. But before we go into the individual lunar features that are covered in this quest, we've got a great graphic here that shows, I said at the top of the show, full moon isn't a great time to be viewing lunar features, is it? Russ, what can you tell us about this image where we're seeing, a waxing gibbous moon on one side, and like we're seeing it tonight, the full moon tonight? Why isn't a full moon good for observing lunar features?
Yeah, well, I mean, we love a nice full moon. It's beautiful. It provides us some nice light at night. But when you're looking at the lunar features, you really get the definition when you get that half light, sort of that terminator line. You get the half light on there. You're not getting all the reflected light from the sun reflecting off that, and you can really get some nice definition to those features rather than just seeing them all in all their glory, certainly. But it's nice to see them without all that light. You can get some of that definition. You can see some of the escarpments, and you get more of that features, those definitions that you can see.
Exactly, when those shadows get cast, that's where the detail really pops out. So, just to explain to people, that is looking at exactly the same place of the moon, when you've got those shadows being cast, and then full moon where everything is evenly illuminated. Now, Russ, let's skip through this quite lightly, these 6 lunar features, because people can learn a lot more when they do the lunar features quest. But let's think about the very first and most obvious features on the moon. They're not the largest, but craters. What do we know about craters? When were they created? Why are they still there?
Yeah, well, I mean, certainly when we look at the terrestrial objects around our solar system, and the moon is no exception, we see that the dominant landform are these craters. These are objects that are traveling at cosmic velocity. They're 20 kilometers a second, 12 miles a second. These are objects that are slamming into the moon so fast, and they're excavating. It's just a hypervelocity impact. So they're excavating material, they're throwing material up. And what we find when we look at the moon is we see the big ones with our telescopes, and you can see lots of beautiful examples of those, of craters on the moon. But if you were to be there on the moon, and we've been there, you would see all the way down to tiniest little micro craters. I mean, they run the gamut in size. So they're really amazing. And they certainly are the dominant feature here on the moon. And their importance, I think, can't be overstated in the geologic features that we're going to see. You really have two processes that are going on that give us our features on the moon. We've got the volcanic, and then we've got impact. And the volcanic are done on the moon, so we've got our impact. We've got our impact craters. They're still happening on a micro level. You take a look around, you can see. Oh, sorry, go ahead.
So I was just going to say that if members are doing this quest, what they should look out for, these are very definitely, you can see down in the bottom right-hand side, right-hand corner there, that's an image snapped of some craters on the Terminator. When they're trying to get their crater images for this quest, try and pick some of the craters that have a little mountain in the center of them, and we can see this. Russ, we've seen this when you see a slow motion of a water drop going into a pool of water, we see this splash back coming up, and that's what we see in the center of some of these craters, isn't it?
Yeah, and that's fantastic. I'm glad you pointed that out. So when we get some of these more complex craters, we're going to see that central peak rising up. Now we do have examples here on Earth of that too. Even here in Texas, we've got a nice example of a central peak. We're not talking about Texas today, but I can't help but bring Texas into most things I talk about. So, if you come to Texas, there's a central peak on your way to Big Bend National Park. But certainly look for those central peaks. Those are more complex craters. You can also look for these real simple, beautiful bowl-shaped craters. Those are simple craters. They look like a little dog bowl on the moon. Really, really beautiful. And you'll see they have well, we're going to talk about rays later, I guess. But if you find the right crater, you can also find some of those rays and some of that ejecta as well.
Yeah. Now, our next feature is really easy to spot, and strangely, they're one of only 2 probably features that are good to observe during a full moon, and those are Maria. What are Maria when they're at home?
I'm sorry, you cut out for a second there, Paul. But I think we're talking about the Maria. So
we are.
I'm gonna jump right in. These dark areas on the moon. Their color comes from the fact that they're iron rich. So they certainly are really astounding to see, and when you're looking at a full moon, to see those nice dark areas. Those are iron rich. Some of them have some titanium in them as well, but iron is really the predominant mineral that's going to give it that dark color, or that low albedo. So you might hear us say the term albedo a couple of times tonight. That's just
what's that?
Reflectivity. Yeah, I can't help but talk about it. So highly reflective areas have a high albedo. So you can see some of those on the image that we're looking at right now. You can see those highly reflective craters down there on the moon. They've been excavated, so we've dug down a little bit into the lower the material that's underneath, we're going to get a higher albedo there. And then we've got the nice dark Maria with that low albedo. So
this is
oh,
sorry, this is a live shot from the Canary 2 ultra wide field telescope in the flagship observatory at the Institute of Astrophysics of the Canary Islands. And this is why a full moon is really cool. It's a good way of seeing the Maria, the seas. But you were talking about craters. These two were caused by impacts, but just giant impacts. I mean, the asteroids and comets that must have created these huge holes, basically, that later filled with lava, they must have been massive.
Yeah, massive and traveling very fast. So yeah, very fast. And that's the funny thing is that's actually more important, right? From a kinetic energy perspective, the velocity that they're traveling. Yeah, but those things, yeah, you can see the Maria, the dark areas, you can see they're circular in shape. They're ancient impacts, and then they filled in with that iron-rich basalt lava, just filled them right in. And you can see there's still some impacts on top of those. It's still happening. We're still getting those impacts. But and not to talk about Texas too much, but there is one of these basins here that's about the size of Texas, and that's my favorite. That's the Embryo Basin. So that's the Maria here. We're going to be looking at, I think, a couple of the craters that are nearby. But that's where the Apollo 15 landed and was able to explore both the highland areas, the lighter areas of the moon, as well as the dark Maria. So the Embryo Basin is about the size of Texas. So love that.
Now, Russ, we're running short of time, so I reckon we should cover two other features. I think we'll leave rills and rims alone. Those are valleys. And I have to say that anybody doing this quest, it's going to be one of the most challenging features that they try and track down. We have given some suggestions. We've got this lovely image graphic, which uses an image from the Canary 1.5 meter telescope. And we've got some suggested features on there. So valleys are really quite a difficult one, rills and rima, mainly because they're small and difficult to catch. But let's cover two items. Let's do Mons and Montes, and let's do bright ray systems. So Mons and Montes, what on earth are they, and why are we using these weird names for lunar features?
Oh, well, let's talk a little bit about how they formed. I mean, the exciting thing I think about lunar geology is that, the moon has about the same lumpiness as the Earth. So it's got some really deep areas and it's got some really high areas, and it's actually about the same proportions as Earth, about 8 kilometers to our deepest areas, and about 8 kilometers to our highest areas if you kind of pick the average lunar level. So, and all of that has to do with the fact that the moon's been pummeled by these fantastically fast objects. And that's what's creating our Mons. That's what, and our Montes. So those are Latin terms. That's where a lot of the terms come from for space is from Latin. Makes them a little more romantic, a little more fun. You have to learn a new word. You can't just call them mountains, right? But all this stuff, all these features, these high relief features, the mountains on the moon, as you might that way, are caused by these impacts. They're piling up material, and you can do this at home. If you go find some flour, which you probably have in your pantry, and you have a marble, put some flour in a pan, drop the marble in there, and you're going to create an impact crater, and you're going to be able to see some of that material that gets piled up on the side, and those are our Mons that are forming on our moon.
Excellent. Now, we are really running out of time now, so I'm going to suggest.
I know. I talk way too much, Paul.
No, Russ, have a look at this. Look, we can just see the pink supermoon poking through the clouds in Chile. This is our new Chile 3 lunar video telescope. And this is exactly actually the kind of telescope which amateur astronomers have used over the last 10 or so years and captured what are called transitory lunar phenomena, which are impacts that are still happening now. But we're going to talk about that with Bob Bowman. I think I should talk about bright ray systems with Bob, because Bob's favorite object is that crater Tycho, and it has that bright ray system. So, Russ, if you don't mind, I'll pick up with bright ray systems with Bob. Would you mind doing that?
Paul,
No
that
offense.
sounds great. I am not offended at all. I will be back on Thursday. Hopefully, some of you will show up, and hopefully, you'll bring your kids to see that. Unless you're
Yeah.
a kid already out there watching this, and I hope you are. This is fun stuff, and we're gonna have a good time.
And the views from that solar telescope last week were absolutely brilliant. A superb active region there, some great prominences coming off the edge of the sun. You're going to have a whale of a time, and I will certainly be tuning in on Thursday, Russ. But for now,
Awesome.
thank you very much for telling us about Slooh's educational products and also some of these lunar features that we're seeing. Thanks, Russ.
Thank you, Paul. Before you let me go, I just want to mention,
Yes.
anybody who's interested in education, reach out to me, Russ at slooh.com. I'd love to have a conversation with you about how we can get your students or your constituents, whatever it might be, working with Slooh. The bigger our community, the better it is.
Thanks, Russ. Well said. Now then, after this short break, Bob Berman is going to be back to answer a stack of questions members have been asking, and we will also talk about bright ray systems and the crater Tycho. Don't go anywhere. We're going to be right back after this short break. Hello and welcome back to Slooh's live coverage of the full pink supermoon. Tonight we've got live feeds coming in from Slooh's observatories in the Canary Islands. Those are at the Institute of Astrophysics of the Canary Islands, high up on a volcano, 8,000 feet, 2,000 meters above the ocean and usually above the clouds. We've got a few light clouds today. Also, we've got live images coming in from our Chile observatory. And don't forget, at the top of the next hour, we've got our first full Spanish show. But for now, I'd like to welcome back Slooh astronomer and author Bob Berman, not Russ Glenn, as it says under there. Hey, Bob, how are you again?
Good, Paul. Good to be back.
Now, listen, we were talking with Russ about lunar features and we ran out of time. So I suggested that we would talk to you and go back to Tycho and talk about bright ray systems before we come on to some of the members' questions. So you were telling us this beautiful crater, which is one of the few objects, once again, these bright ray systems, those and the seas are two of the best objects to look at during a full moon. What can you tell us about this? How come it is so prominent, this crater, and these bright rays coming from it, Bob?
Things changed on the moon about a little over 1 billion years ago. Before that, during the other geological periods, the Nectarian, the Eratosthenian, the Embryon periods, all named for major events or eras when things happened on the moon. Well, starting about a little over 1 billion years ago, when impacts occurred on the moon, meteors or asteroids would hit the moon, the material from underneath would be excavated out and thrown to big distances. And that material was almost always whiter and brighter than what's already on the surface, particularly because sunlight has a habit of darkening the surface. So, because of that, the newest craters show up as white, and we see them best now at full moon. So, look around the moon right now during this live image, low magnification, wide field, and look at all those white spots. Every one of those shows you a place where there was a recent, meaning in the last billion year, or the Copernican era of the moon, impact. And of all of them, the most prominent, if we could just get rid of those words below, because that's blocking out Tycho. It's right in front of Tycho. So we need to get rid of that's it.
Excellent.
Great.
Well done,
So
studio.
now look at that near the bottom. You see that round white crater, which by the way also is surrounded by a slightly darker gray halo, kind of a mysterious halo around it. And then from there on outward are those white rays. Trace them, and you'll see some of them go clear across the freaking moon's surface all the way to the other side. What's going on with that? Because the other craters, look at Copernicus on the left side of the picture. That was a nice recent impact. That was about 800 million years ago. Tycho at the bottom was only 100. Some say 200, but the recent evidence says that it's actually 108 million years ago. That's very recent. So because of the recency, the whiteness, the white lines have been thrown in all directions, and they're best seen at full moon. So since that's best right now at this lunar phase, let's enjoy them.
So there were some dinosaurs. If they looked up, early dinosaurs, if they'd looked up, they could have seen that enormous impact. My God, what that would have looked like, Bob.
That's right. They would have been puzzled if their brain had been bigger than a walnut. I think the Stegosaurus only had a walnut-sized brain. What size brain do you need to actually say, "Hey, something just hit the moon"? Maybe a little bigger than a walnut. But if they could have done that, yeah, they would have been amazed. But that's what it's come to, Paul. You and I speculating about the IQ of
Dinosaurs.
creatures that are no longer alive.
Okay, so and let's not venture into politics on size of brains. Now we've got some great questions. We'll get through as many of these as we can in the next 10 minutes. Got some great questions. Now I'm going to start with one that you said was reasonably easy. Now we've been looking at what's called the near side of the moon tonight, the far side we never see from Earth. Now Daz has asked, he's heard that the moon's crust on the far side of the moon is thicker than the crust on the near side. He's heard a couple of theories and wondered if you had an opinion on this, Bob.
Well, no doubt it has to do with the tidal forces of the Earth. The center of mass of the moon also is not in the geometric, if that's the right word. Geo means Earth, so maybe we'd have to say selenometric.
Yeah.
Of the moon is not quite in the center, but displaced by about a mile. So there is asymmetry, and no doubt that's caused by the moon. You know, we are 81 times heavier. Earth is 81 times more massive than the moon is, and if the moon influences us with tides, which it does, and especially now with tonight's full moon being a close by moon, a perigee moon, a supermoon, we have unusual tides, very strong tides tomorrow. If you live near the shore or in a place with tides, look for them. You're going to see higher highs and lower lows thanks to the moon pulling on us. Well, imagine what we do when we pull on the moon. The moon actually pulls on the solid part of Earth, displaces the solid crust of Earth by about 10 inches. So we displace the moon quite a bit more. So no doubt the difference in the thickness of the lunar crust on the two sides, the hemisphere toward us or away from us, just has to do with the difference in the tidal effects.
Okay, thank you, Bob. Next question is from Alan A. And I mentioned this particular phenomena when I said, "Oh, look at this, Bob. This is we're just peeking through the clouds. This is the new Chile 3 lunar telescope giving us a live video view of the moon. The clouds are blotting it out a little bit, which makes it very difficult actually for the camera to adjust exposure. But do you recognize the feature that we are looking at there?
Yeah, if we could just pull back a little bit, it would be a lot easier for
We
me if we go.
can't, I'm afraid. So it's a
Yeah,
very
I know.
tight zoom on this.
Yeah,
Oh, it's
we're
disappearing
zoomed
again.
in. I could rattle off all the lunar Mariah, the lunar seas, but in this case, I'm looking at a blotch so closely that I can't tell whether that's Mare nubium or Mare vaporum. You need to just go back a little bit more to see it. It's sort of like
Yeah,
when you're in the night sky. If you know the stars pretty well, many of us, if we just saw one star, we'd be able to say, "Oh
exactly.
yeah, that's Sirius," just judging by its brightness and its color. But it's easier, isn't it, if we can see the constellations, we see the patterns that are around it. So that's true too of the moon as well. Oh, good. We're panning a little bit, and
Okay.
uh,
So is
that's
that Imbrium?
no, it is not. But if we could pan a little bit more, I mean, they're helping out by
It is.
panning. It's really good.
That's great.
It also should be. Well, you know what? That does look like. No.
We'll
No,
find out, Bob. We'll
I need a
find out.
wider I need a wider field.
Yeah, we'll get the telescope operator to buzz me a message. Let's go on to the next question from Alan A. So this is about this strange thing called transitory lunar phenomena. Now, Alan says NASA found that during a full moon, the lunar surface is disturbed by Earth's magnetail stirring up lunar dust storms and causing static electric discharges. And he wonders if they could be the causes of the light flashes, these things called transient lunar phenomena. And he wondered whether or not you or I have ever seen any of these phenomena and whether or not we can tell them a little bit more about them.
Well, I'll tell you a little bit more about them. I've been watching the moon now for more than 60 years, and not just casually, but telescopically. I've got to have seen all these features at least 500 times. I have never seen any bright glows or flashes or anything on the moon, but I really believe the people who have. They've used generally very large telescopes. Oh, you see there, that's Tycho. I can
That's
tell you
Tycho
now
coming in. Yeah,
where I mean, look at that dark halo around Tycho. By the way,
beautiful.
it's quite clear. And to the lower left of Tycho, now we're seeing the great crater Clavius, one of the larger craters. By the way, Tycho and Clavius were both in the movie 2001: A Space Odyssey. They played a role, one of the lunar bases and the places where the magnetic phenomena were, and they were, of course, Dr. Hayward Floyd was up there investigating all of that. So it played a role in Arthur C. Clarke's book and movie about that. Okay, so transit lunar phenomena that glows and flashes. Generally, they've been seen with 40-inch, 60-inch telescopes, very large telescopes. There have been some spectrographs made of them, which has shown molecular hydrogen to be the source of the light. That was the only one that I know that was taken. And if it was molecular hydrogen, it really suggests that there's outgassing, that there may
Yeah.
actually still be stuff inside the moon that's escaping through fissures and producing the glows that are occasionally seen. But I'd love to see one. Never have, and I'm sure you never have either, right?
I haven't seen one live, but we've seen some recordings by amateur astronomers when they've captured it with video, and certainly those two that we saw were thought to be meteoroid impacts because of the immediacy of the flash. But I was reading before the show over the weekend, actually, Bob, about this 2000, I think it was 2018 study where they were saying, it's possibly gas coming up and releasing a cloud of light material, and that's what people are saying, because those events are lasting slightly longer than these immediate
Exactly,
asteroid
exactly,
impacts.
exactly, exactly.
So,
Yes, yes, yes.
Bob, let's finish off here. We had some other questions that we're going to deal with actually in next month's Supermoon show, which is a flower moon, and that's all about how the moon affects wildlife. And we'll also deal with Daryl Salisbury's question there, and that was about the moon receding and the impact that has on Earth's speed.
Oh yeah, that's
The way
fascinating.
it's
That's fascinating.
that's spinning.
That's fascinating.
But
Well, when he's saying the moon is receding, what impact does it have on Earth? It's really the other way around. It's the fact that the Earth is slowing. Well, it's a mutual reaction because it's
it,
the angular momentum of the Earth Moon system are tied together with both objects. So here's the moon pulling on the Earth tidally, especially on the oceans hitting the shores, especially on that 3 foot high bulge of seawater, which by the way grows to 5 feet when it reaches the shore, and that slows Earth. Everyone has heard that Earth is slowing, but Paul, I'm amazed that it's so widely known because it's so subtle. The public generally is not very good at grasping subtle and or barely there phenomena. And here we're talking about you know the degree to which the Earth is slowing its rotation. I'll tell you.
no, I don't.
After a whole century, after 1 century, the day has become 1/700th of a second longer. Each day is
Yeah.
now a 700th of a second longer after a century. And it's the moon doing that to us. But once we slow down, the moon is tied in with this loss of energy that we've experienced. So the moon gains energy because of our loss, and it uses that energy to spiral away from us. And we're talking about spiraling away a few inches a year, very slow, but nonetheless, it's having that effect and will continue to until it becomes tidally locked, until its day and its month are the same. In other words, the spinning of Earth, which currently is 23 hours 56 minutes and 4.1 seconds, will become the same as the month. As we know, the month is 27.32166 days. They're both growing until they're both 40 days long. It's almost biblical, 40 days and 40 nights. That will be the
Mm.
month, and that will be our day. So that's what the moon is doing to us.
So Daryl's one of his supplementary questions was, will we have to change our clocks anytime soon? And I think the answer to that one, Bob, is a definite no. By the way, we were seeing, apparently the Slooh Ops have told me we were seeing the Sea of Tranquility before, centered on the Apollo 11 site. So that's what we were looking at there. Bob, thank you so much for joining us tonight. It's the end of the show. Hopefully we are going to see you back next month. And hopefully members listen to you every night because you actually do a lot of the narration for a lot of the live missions, which is pretty cool. And I think you're a firm favorite with Slooh members, so you're a legend, Bob. Thank you very much for joining us tonight.
Well, thank you, Paul. My pleasure.
Wow, what a night we've had. Where does an hour go? It almost goes by so too quickly. When I was talking to Bob actually before the show, we were saying, well, we're in lockdown, we could quite easily go on for 5 hours, a whole night talking about this stuff because we love it. We hope you love it too. And frankly, if you're here at the end of the show, you probably do. If you speak Spanish, you're in for a great surprise because in half an hour's time, we've got the whole thing over again, not with me because I don't speak Spanish, but with Daniela Fernandez, who is our resident astronomer with our partners, the Catholic University down in Chile. They operate our Chile Observatory. But anyway, for tonight, let's wrap up. Don't forget, Russ Glenn will be on air for our homeschooling lesson number 2, that very special solar show. That's on Thursday, 1400 UTC. That's 10 a.m. EDT. And that's got live views from the Canary Islands Observatory's special solar telescope. It will knock your socks off. Loads to see, lots of interesting. And there's a quest as well that anyone can do there. Mike Shaw is back at Nightscape. So if you've got a DSLR camera, then Mike tells you how you can take fabulous nightscape shots. What he does each week is he focuses on an area of the sky. So the Slooh telescopes are looking at the objects with high power in that region of the sky while he's explaining and teaching members how to take astonishing nightscape photos. That's on Tuesday, April 21st for the next installment of that. And we will be covering next month's Flower Supermoon, the last full supermoon of 2020. Hopefully, we will get to cover some of the subjects that we didn't cover tonight. But that show is really going to be focused very much with some special guests who can tell us all about wildlife and the effects of the moon on wildlife. Things like the Great Barrier Reef that spawns a night or two after a full moon in, I think, October. So anyway, thank you very much for joining the Slooh team tonight and Slooh members around the globe. Don't forget, half an hour's time, our Spanish language show, hosted by Daniela Fernandez. And we'll carry on with these superb live views of tonight's full pink supermoon. Hope you enjoyed it tonight. Thank you very much for joining us. Bye for now.
I'll grab a piece of the moon for you. Cut the cloth of the stars, or the sun for a crown for you, for you. All these things I would do, all these things I would do for you, but all I can do is sing. Catch the wind in a bottle for you. Sound of rain to sleep. A sunny day to keep for you. For you. All these things I would do. All these things I would do for you, but all I can do is sing. For you. For you. And I'll let you cast your shadows where you will, and I'll watch you make your own way up that hill. But I'm with you tonight, and I always will be, if you need me. I'll bring an ocean of love for you. Gather wisdom in a shell, oh, a chest full of hope for you, for you. All these things I would do, all these things I would do for you.